Diodes. Semiconductor diodes are joined with N-type and P-type semiconductors. There are several types of diodes. 1. Ordinary rectifying diode. 2. Zener diode. 3. LED, light-emitting diode. 4. Photodiode. The diagrams show how an electrical current flows through a diode. 1. When the positive pole, plus, of the battery is connected to the P side and the negative pole, to the N side. The positive holes of a P-type semiconductor and the positive pole of the battery repel each other. And the free electrons of an N-type semiconductor and the negative pole of the battery repel each other, thus pushing them towards the p-n joining area. As a result, the free electrons and the positive holes attract each other, thus allowing the current to flow across the p-n joining area. 2. When the connections at the battery are reversed, the positive holes of the P-type semiconductor and the negative pole of the battery attract each other, and the free electrons of the N-type semiconductor and the positive pole of the battery attract each other, thus pulling away from the p-n joining area. As a result, a layer that contains neither free electrons nor positive holes is created at the p-n joining area, thus preventing the current from flowing. Ordinary diode. 1. Description: an ordinary diode allows the current to flow only in one direction, from the P side to the N side. 2. Characteristics: a minimum voltage is required for a current to flow from the P side to the N side. Here are examples of voltage requirements. Silicon diode A, about 0.3 volts. Germanium diode B, about 0.7 volts. The current will not flow if a voltage is applied in the opposite direction, from the N side to the P side. Although an extremely small current practically flows, called the reverse leakage current, it is treated as non-flowing because it does not affect the operation of the actual circuit. However, if this reverse leakage voltage is sufficiently increased, the amperage of the current allowed through by the diode will suddenly increase. This phenomenon is called diode breakdown, and the voltage that is applied is called the breakdown voltage. 3. Rectification function. 1. Half-wave rectification voltage from an AC generator is applied to a diode. Since the voltage shown between A and B is applied to the diode toward the forward direction, the current passes through the diode. However, because the voltage shown between B and C is applied to the diode toward the reverse direction, the current is not allowed to pass through the diode, since only one half of the current which is generated by the generator is allowed to pass through the diode. 2. Full-wave rectification. When terminal A of the generator is positive, terminal B is negative, and the current flows as shown in the upper diagram of illustration 2. When the polarity of the terminals is reversed, the current flows as shown in the lower diagram of illustration 2. This means that output current always flows in only one direction through resistor R. Application example: ordinary rectifying diodes are used as rectifiers for alternators. Zener diode. 1. Description: while a Zener diode allows current to flow in the forward direction in the same way as an ordinary diode, it also allows current to flow in the reverse direction under certain conditions. 2. Characteristics: in the forward direction, current flows from the P side to the N side through a Zener diode in the same way as an ordinary diode. In the reverse direction, a current exceeding a predetermined voltage flows through a Zener diode. This is called a Zener voltage, which remains practically constant regardless of the amperage of the current. A Zener diode can be assigned with different Zener voltages depending on its application or purpose. 3. Application examples. Zener diodes are used for various purposes, one of the most important of these being the voltage regulator for an alternator. The output voltage is controlled constantly by incorporating the Zener diode into an electrical circuit. LED, light-emitting diode. 1. Description: the LED is a p-n-joining diode, which is the same as an ordinary diode. It emits light when a current passes through it in the forward direction. LEDs can emit light in various colors, such as red, yellow, and green. 2. Characteristics: LEDs have the following characteristics: smaller heat generation and longer life than ordinary light bulbs. Emit bright light with low power consumption. React with low voltage. Quick reaction speed. Three. Application example: LEDs are used in high-mount stop lights and indicator lights, etc. Photodiode. Click on the appropriate button in the illustration. 1. Description: the photodiode is a p-n-joining diode that consists of a semiconductor and a lens. If a reverse direction voltage is applied to a photodiode that is exposed to light, a reverse current will flow. The amperage of this current will vary in proportion to the amount of light that falls on the photodiode. In other words, the photodiode can determine the amount of the light by detecting the amperage of the reverse current where the reverse voltage is applied. 2. Application example: photodiodes are used in the solar sensors for air conditioners, etc. Diodes.